Yeah.
Yes.
I join you. I'm not too smart either, but my question is, was the Viking science that was done underrated? And also, if you drive down the 605 freeway, you'll see a river, the San Gabriel River, which is kind of looks like a river on Mars. There's only occasional sewer water flows that go down that river. It's a dry river, but beneath the San Gabriel River is a vast groundwater basin all the way to the ocean.
And that's the idea behind the Northeast.
So I vote for an area that like the 605 freeway.
Well, we don't, if the 605 freeway was on Mars, we'd see it with our imager.
So let me ask everyone, actually. This gentleman has given us his vote, and we've done this before. So I'm going to ask you, the first is Jezero Crater, which is the delta. The second is Northeast Syrtis, which is the groundwater environment. And the third is Columbia Hills, which is
Hot springs.
Hot springs. So give it some thought. It's very important. Now, you're ready to vote. Okay, how many for Jezero Crater? How many for Northeast Syrtis? And how many for Columbia Hills? Ooh.
We like hot springs.
We like hot springs. But I'd take vacations to hot springs all the time, right? So does that reflect the votes, what you just saw in the distribution here? Does that sort of reflect what happened?
No, it does not. Okay, so now let's have the other side of the coin here, okay? So there's pluses and there's minuses, right? It's like everything in life. Okay, so what could be wrong with going back to the Columbia Hills?
You've been there already.
You've been there already. There's some other things that aren't so good about it. It's dusty location, so the rocks aren't exposed very well. There's no stratigraphy that we've been able to fathom, even though we had the Spirit rover there. There are a diversity of rocks, but let's say you go to the centers and you get the silica and you see no evidence for life. Kind of struck out, huh?
Is that not true everywhere, though, at all three? I mean, you can't know ahead of time which one's going to be the bonanza, right?
That's right, and that's the hardest part here. So it's not just the material that might include the life, it's the other stuff around it as well. And back to the question about Viking, so those landers were incredibly sophisticated. And what they brought and landed on Mars were probably more the public view, the common view that life existed on Mars. However, before those spacecraft ever got there, we already knew that the surface pressure was below the triple point of water and that liquid would not exist on the surface. So we kind of already had hints that Mars wasn't a particularly habitable place. Nevertheless, those spacecraft sent 4 incredibly sophisticated, in fact, groundbreaking, because at the time, we didn't even know how to measure life or how to test to see if it was there. And there were 4 incredibly sophisticated instruments that were brought down. There's a scoop that went out and picked up that material, and it put them in these 4 different instruments. And one of them was like putting it into chicken soup and seeing if you had biologic activity. Another one was looking for organics and carbon and so on. It's a long story, but 3 of them came up completely negative. No evidence for organics of any kind. And part of the thought there is that the ionizing radiation, this atmosphere is so thin, that would go through, and organics don't stick around when you have radiation. We like to have magnetic fields and big atmospheres to shield us. So it's possible that even if there were organics, they've been destroyed with time. So 3 of them came up negative. The 4th came up and they looked at it more carefully and they decided it was probably oxidation within the material and thus no evidence. But the end result of all of that hard work was no life. So let's carry that forward. Well, you went to the wrong place. You should have gone over there. So do I send that same spacecraft there? And then if that's not right, where do I go elsewhere? And it's a needle in a haystack search. Okay, you keep going over and over and over, and you come up. So the next question is there any place on the surface now where liquid water is stable? We already told you the answer to that, no. So there's no obvious environment at the surface where you're going to go to find life. So the scientific exploration that we're doing is more towards, okay, even if we went to these locations and we came up negative, and these are among the best locations where life could have existed at the time, we still are going to learn about the environment that existed on Mars and how the planet evolved and changed with time. So you won't come up striking out totally. You'll still get at what the basic environment was and how Mars has changed. And that's something you can do scientifically.
And that brings me to my next question. Mars 2020 rover, which doesn't have a name yet, right?
No name yet.
When will that part happen?
Probably not till closer to launch.
And it's quite a lot like Curiosity, is that right?
It's almost exactly the same. They took all the spare parts and they swept them together, and including the same sky crane landing system and so on. The only swap out they did was 2 swap outs, actually. One was the wheels on Curiosity weren't doing so good, so bad design, those are being fixed. And the second is it won't have chemistry and laboratory instruments inside the vehicle. Instead, it will carry this caching and sampling system that will cache the rocks and put them in test tubes and carry them around until it leaves them on the surface. So that's the main difference.
So that's the next question after that. If you're going to cache samples and leave them for someone else to come pick up, where does that part of the story come in? Is there a plan for a follow-on that will go pick up those samples?
Yeah, that's right. So there's 2 ways to think about it. If you found spectacular samples, that might be the impetus to really want to go back and get them. And to go back and get them is a tough thing. Getting samples back from Mars is a huge engineering challenge. So we've collected the samples, we've put them into our little test tubes and hermetically sealed them, and we've left them on the ground. So now we need the next mission to go get them. And it needs to put them into a sphere, and it needs to put them inside that sphere, and it needs to close that sphere such that no material from Mars will come back to Earth except the stuff that's inside it.
Why? Why
Because
is that
if Mars is teeming with bad microbes, it could come back to the Earth and kill us all. I think there was a book called about that, right?
I see.
So the current protocol is to break the chain between anything from Mars that you bring back. When you do get it back to Earth, and I've left out the middle engineering part, it needs to, and I'll get back to it, it's pretty cool. So, it needs to go into a facility that is more safe than the Center for Disease Control, most sequestered place on Earth. There's no such thing exists yet. It will be brought inside there, and what's the first thing that you do to it? You feed it to rats. See whether or not they die or not, right?
Wow.
Right. So you just take, these are the most expensive rocks in the history of mankind.
That's amazing.
Well, you can also irradium and do other stuff, okay? Okay, so now you have the sphere sitting on the surface of Mars, but you want it here back on Earth. So now you got to take that sphere and you got to stick it on top of a rocket. Well, in order to get the rocket there, you have to land the rocket, right, from Earth. So you got to send a rocket to Mars. And you either have had a fetch rover that went and got your samples and brought it to this location, or it goes together. That could be 1 or 2 missions, depending upon how you do it. Now you have the sphere, it's on top of the rocket, you light the fuse, and it goes up. But it can't come all the way back. It has only enough fuel because you had to land it there, and it's really thin atmosphere is really hard to do, okay, to get it into orbit. So now you've made another satellite around Mars. Okay, so you got Phobos, Deimos, and this sample canister. Okay, but you want it back on Earth. So now you got to send another mission that will go and capture that little satellite, this sphere that's going around Mars, collect it, and bring it back to Earth.
Isn't that, though, a little bit like the Apollo program, and that you send something, you drop part of it down there, instead of humans, a robot would go collect up the things, it's all figured out, and then it just comes back up and rendezvous and...
Yeah, it gives you a new meaning to planetary protection. We've littered the hell out of Mars.
Yeah, it's true. And we were, leaving our things there all over the place. But I guess I'm trying to say, it doesn't sound like it's out of the engineering realm.
Totally, no. It is extremely difficult. It would be fairly expensive for all these missions, but it is completely doable. And I think in some ways, the proof will be in the materials we find, what we can see with Mars 2020 that would compel you to want to bring those samples back. Do you see organics in those samples? Do you see what could be tests for organisms that were there? Those sort of things would make you want to go and get them.
So we'll be able to do some amount of testing in situ on Mars,
yes, it
and
actually
then save the goodies for later.
So
if we
the
want
instruments on Mars 20 are even better than those on the last one because technology always improves. So this thing has it has two instruments that will basically produce at the grain scale within a rock the elemental and the mineralogy of all of those materials. Another one will determine whether there's any organics, any peptides, any organics of any type, and will identify in some sense what they are. And that will be then, think about it. So you've gone and you've tested the material. Is this the silver bullet that you want to bring back? Okay. And then if the answer to that's yes, you've put it into a test tube, but you only have so many test tubes. So you got 45 test tubes, you only bring back 30. And now you've left them on the ground. Oh, wait, we could have 4 different science conferences where scientists just fight about which samples to go and get and bring back. Which ones are the right ones?
You've got a job for decades.
Oh, not me, but somebody.
Are we working on that? Is there activity at JPL developing some of these technologies?
Yes, so there is an advanced, that's what we do at JPL is build spacecraft, and there are various scenarios for all of those to complete that sample return.
Yeah. What year would that be completed? Because to me, in my mind, I'm probably thinking what a lot of our audience is aren't we sending people there in the future, or could we send humans to pick up this?
Well, let's see. The last administration has left, and we haven't heard what the new administration thinks. Yeah. So, but NASA had been saying for sending people in the 30s.
Yeah.
Whether that's possible or plausible, or there's enough money.
Would people beat the robotic return missions?
In general, most of us think it would be prudent to prove that you could do the round trip with just rocks before you send human beings. Seemed to make kind of sense to me.
Tony.
I just have a question. I've heard Gil Levin speak, who designed, I guess, the one possible detection experiment in Viking.
Yep.
And to me, it seems like a pretty simple argument. Why not repeat the experiment, modifying the procedure with what we learned since Viking?
So it was a gas release experiment,
right?
And it was not by itself capable of determining whether there was life or not. So basically, it was taking soil sample and putting it into a reagent, and they got a rapid gas came out of it. And one interpretation of that is that there was bugs that were happy because they got that reagent. The other is that there was just oxidizing material in the soil and then with time the oxidation died out and there was no more oxygen coming off. So that's we should do a better experiment that more specifically goes towards life.
Because the other part of that was they took a sample, heated it
Yep.
a lot, and then did the same
Yep.
thing,
Yep.
and it didn't
So,
produce that
so,
reaction.
so far better is just, are there organics at all? And you can determine that in a remote fashion now. You don't need to destroy the sample. So,
Yeah.
the instruments are way better than they were.
So we have time for just a few questions from the audience. I see a hand up there.
Yep.
Two quick ones. Is there the possibility of an international effort and possibly public-private? And then would the International Space Station be the repository of the material rather than Earth?
Yeah, so the answer to the latter is easier. And so you've spent how much money on the space station, and you bring a potential cast of stuff that could completely make it inhabitable. So that ain't happening. I mean, now you have a space station that's infected. So no, I ain't doing that. That's too expensive. That's even more expensive than the Center for Disease Control thing we need to design and build than where this sample is going to come down. Okay, so then international cooperation is always a possibility. And in fact, most missions to Mars have components of things that are built in other countries. The InSight lander, which is going in 18, will be there. That's before, maybe you'll have me back for that. So that one has lots of European instruments. There's a French seismometer, a British seismometer, a German heat flow probe, and a Swiss electronics. And those are all on a U.S. built. So yeah, international cooperation always happens. Yeah. And then the wild card is, as you said, private. And you're already starting to see that. There was just an announcement of SpaceX taking some tourists around the moon. They've already announced that they're going to take their Red Dragon capsule, the big 7-passenger thingy, without people and send it to Mars in 2020. So that would land in a totally different manner, lots more mass you could get in the ground.
So they could go to the Highlands because they don't need a parachute.
No, they still need atmosphere. So you'd use the friction of the atmosphere there more so. But you fly horizontally through more of it, so you get more. You change the CG of the spacecraft, and in fact, you do that while it flies. So the scenario is you come in just almost like a rock until you get down to the lowest elevations. You then fly horizontal for kilometers as this thing slows it, and then it just kind of falls down, fire rockets, and it's down the ground. No parachute. It's totally, if they could do it. Unclear. Originally they said just a couple of days, but later they've said maybe longer. Don't know. I don't think they've.
The propulsion part that's not battery powered.
No, not battery powered. Lots of fuel.
Question there.
So for the generation that's going to be lucky enough to go to Mars, what you're a geologist, which isn't an astronomer, what other fields are going to be of interest to send to Mars?
Let's see.
I'd like to repeat that for the live stream audience. So for the generation lucky enough to go to Mars, besides being a geologist, what other fields or disciplines are going to be needed?
Lots of doctors, because you're going to get sick. What are cancer guys called? Oncologists?
Oncologists, yeah.
I don't know about that lucky part about going. Sorry, don't want to, that's bad. But okay, but the key to the question, and the one I'd really like to answer, is if we're going to send people to Mars, let's have them do something useful. So they shouldn't just read books and drink coffee. Okay, not that that's not useful, but if they're on Mars, they ought to do something out in the field. So having a geologist's brain that's there, that could see stuff, and right now the rovers that we operate, everything takes forever because it's a one thing a day, kind of, one thing per sol on Mars. The commands are set up as a package in the morning. The rover gets it. There's no contact with the rover while it does its entire thing for the entire day. And at the end of the day, it calls home. So it's like sending your kid off to college. Did you do good or not? And you don't know till the end of the day when you get the phone call back, right? So that takes a long time, right? But if you had a brain there where you can interrogate the rocks and you could do stuff way, way faster. So field geologists, if there was any field biologists, that kind of thing. And maybe even an astronomer.
Maybe even an astronomer. Any other questions from this side? Yes.
Are there design proposals being considered to land and traverse the equatorial highlands at some point?
Yeah, the hard part is, again, having enough atmosphere to land in the highlands, and that's why we tend to be in the low areas. I'll give you a slight, so here's our topo map, and so notice this is highland crust for Jezero Northeast Syrtis, but it's lower in elevation. So, and there's big chunks in here that are basically highland crust, but they're lower in elevation. So in a sense, Opportunity's already been looking at some of the Opportunity rover now is in Noachian rocks, the oldest age of rocks on Mars. So yeah, we can do that without actually having to go up to the top. Just for comparison, the current spacecraft use a heat shield to use the atmosphere, the friction of the atmosphere to slow it. The volcanoes are so high that those spacecraft are still not off the heat shield when you'd be going by them. So you can't possibly land up there. It's just too high. There's no atmosphere to help you.
The blue color, what is it?
The blue colors are the low areas, right? Yeah, so these are like 5 kilometers lower than these. Quite a bit different, yeah.
And our last question.
Doesn't Mars have caves, and couldn't that be a way to live there without perhaps getting cancer?
Yeah. So,
the question is, doesn't Mars have caves, and isn't that a place we could live without getting cancer?
yes, so we have identified holes from space that are in volcanic terrain that look like lava tubes, emptied lava tubes. And those almost certainly go underground. And if you've been to Hawaii and other cool places, you've been in those. And so, yes, you could, you'd be living underground, but you could do that. And that would give you the rock over you to keep the radiation down. Yeah. Yeah. The alternative is there, most of the surface has soil and regolith. And if you brought a few Cat-9s, you could just
So this gives us an opportunity to once again thank our spectacular guest, Matt Golombek.